Okay, let's work on section 1.3, segments, rays, and distance. Before we start, let's work on the warm-up. Sketch 3 planes intersect in a point. All right, try it. Sketching is an important skill when diagrams are not given, and there will be a sketching problem on the test and the quiz for this chapter, so you need to practice this. So stop here and come back when you're done. Okay, so 3 planes intersect in a point. If you recall, the 2 planes intersect in what? They intersect in a line. So let's just sketch that first. Here is one plane, and then here is another plane. And then here is the intersection, which is a line, right? So we want to draw another plane that is intersecting these 2 planes and then intersect in a point. So what about something like this? If I draw a plane that goes through middle of the both of these planes, so it cuts in to like this. All right, let's just make this a little shorter so you can see better. So it goes in like this and like that. So this third plane is actually going to cut through like this, like that. So the intersection is a point. You see it? So there are 2 planes, one going like this and another one going like this, and then the third one is going down like this. So the intersection is a point. Okay, all right, let's start the section. Okay, so we are on section 1.3, and objective for 1.3 to 1.5, so the definition postulates here. So we did the basic figures, the points, lines, and planes. Remember, these are the 3 undefined terms, okay? And here are the objectives. And for this section, we have the objective 1 and part of the 3, okay? You need to write down the objectives so that you know what objectives are. Just reading, it's not going to stick in your mind. That's why I'm making you write this, okay? So use symbols for lines, segments, and rays, and distances, and find the distances, and state and use the segment addition postulate. Okay, and postulate is probably a new word for you, so I'm going to explain what it is later. Okay, and objective 3b is angle addition postulate, which we will do in 1.4, which we learn about angles. Okay, and what else? The symbols for lines, we already learned this, you remember? These are lines, line symbols. And then now we are going to learn symbols for segments and rays and distances. Okay, all right, let's get going here. Okay, so key concepts: segment, rays, and distances. Objective number 1. The segments and rays. In the diagram, point B is between the point A and C. Note that B must lie on line AC. Okay, so these 3 points are collinear. You remember that word? Segment AC, the segment AC right here, denotes this line right here, and AC. So line AC is like this, right? Segment AC doesn't have the arrows because ends at these 2 points. Consists of points A and C and all points that are between A and C. Points A and C are called endpoints of AC. Okay, so these are endpoints. You remember line has no ends. It continues forever. And A and C happen to be on these lines. So this line we can call it line AC, but we can also call it line AB or line BC because those are points on the lines and then it continues forever. With segment AC starts here and ends here. So if there is a point B here and then you say segment AB, then segment AB and segment AC are different segments because it has different lengths, whereas line AB and line AC are the same lines. Okay, ray AC denoted with this right here, okay, consists of the segment AC and all other points P such that C is between A and P. The end point of AC is A. The point is named first. Okay, so ray AC is segment AC plus all the points beyond C going this direction. Okay, but not this way. So this is the end point, and all these are on ray AC. So ray AC and ray AP are the same. Okay, but you cannot write ray CA because then that means end point is here and then it's all the points going this way. That's a different ray. A through C and then forever going this way is not the same ray as starting a C through A and going it this way. Okay, so these are not the same, but these are the same. Okay, all right, opposite rays and number lines. The ray SR and ST are called opposite rays if S is the between R and T. So ray SR is this one and ray ST are this one. And both endpoints are S and go in different directions. These are called opposite rays. And they are not the same, they are different rays. The hands of the clock shown suggest opposite rays. On the number line, okay, so if this is like 6 o'clock, right? So that's one ray, and that's another ray. But it has to be in a straight line, right? If it's S have to be between the R and T. It has to be a straight line to be opposite ray. So if you have something like that, these are not opposite rays. Okay, opposite ray have to be, the points have to be in between. Okay, a number line, every point is paired with a number and every number is paired with a point. In the diagram, point J is paired with -3, the coordinate of J. Okay, so J's coordinate is -3, K's coordinate is 0, L's coordinate is 2, M's coordinate is 4, and so forth. Okay, next page. So here's the example, okay, of the number line and the distance and so forth. All right. Wait, I'm sorry, page 4. Page 4. Where's page 4? Oh, over here. Sorry. Length and the distance. This, you remember what this one is? This line right here, is that ray or line or segment? When there is no arrows, it's a segment. It's ending at M and J. Okay, so the length of MJ is denoted by MJ. This is the segment. When there is no line above anything, this is a numerical value, the distance between M and J. This is a geometric concept of segment. This is the numerical value of the distance between 2 points, okay? It's the distance between point M and point J. You can find the length of the segment on the number line by subtracting the coordinates of its endpoints. So you remember in page 3, M was here and J, M was here and J was here, right? So segment MJ is this segment right here. And the distance of these 2 points, the MJ, is this distance. 1, 2, 3, 4, 5, 6, 7. It's a 7. Okay, so you can use equal here because this is a numerical value. It's the distance between M and J. You cannot do this. No, because this is not a numerical value. This does not equal 7. Okay, MJ equals 7. This is more like a figure. Okay, it's not a numerical value. Okay, all right, so okay, so the distance between the point M and J, you can find the length of the segments on the number line by subtracting the coordinates of its endpoints. So 4 minus minus 3 equals 7. Oh, here's the number line here. So between 4 and minus 7, you can count it. 1, 2, 3, 4, 5, 6, 7. There are 7. Notice that since the length must be a positive number, you subtract the lesser coordinate from the greater one. Actually, so even if we say Jm or Mj, doesn't matter because distance is a numerical value, so which order it goes doesn't matter. Actually, the segment Mj is same as the segment Jm. Okay, the order, direction doesn't matter. The ray does matter, but line and segments, the order of the alphabet doesn't matter. Okay, so if you do minus 3, okay, so even if we change the order, you still do 4 minus minus 3 equals 7. However, actually the distance between the 2 points is absolute value of the difference of their coordinates. When you use the absolute value, the order in which you subtract coordinate doesn't matter. So if we do minus 3 minus 4 equal minus 7, but we put this in absolute value, so this is 7. Okay, so if you use absolute value, the order doesn't matter. So between J and L, 1, 2, 3, 4, 5, there are 5. 3 minus 3 minus 2 equal negative 5. In absolute value, that's 5. Or you do 2 minus minus 3 is 5, and that's 5. And here's the generalized points for X and Y. Okay, postulate number 1 and number 2. So these are the two the first postulates that come out in geometry lesson. The postulates are the accepted truth that we cannot prove, but we have to start from here. There are certain things that are accepted as true, like undefined terms, the points, lines, and segments. The postulates are kind of like undefined concepts. If we can prove them, they're called theorems. But if we just accept as universal truth, they're called postulate. Okay, so the Ruler postulate, the points on the line can be paired with the real numbers in such a way that any 2 points can have coordinate 0 and 1. Okay, so that any points can have numerical values to convert that distance into numerical value. Once a coordinate system has been chosen in this way, the distance between any 2 points equals the absolute value of the difference of the coordinates. Okay, so that's what we just did here up here. Postulate number 2, segment addition postulate. If B is between A and C, then the distance between A and B plus distance between B and C equal the distance between A and C. Okay, but A is between B is between A and C. So here's A, right? And here's C, right? Here's a line. Between means you have to be on this line. Okay? Then this distance plus this distance is this. So you cannot do this. A and C. So here's a line, right? A and C. And you cannot do B here because it's not between A and C. Because then AB plus BC is not going to equal AC. Okay? B have to be between A and C. Okay, so page number 5. Here's an example. B is between A and C, and AB is X, and BC is X plus 6, and AC is 24. Find the value of X and find the distance by BC. Okay, so AB plus BC equal AC. All right, you can do this, right? So you can do these, finish these, okay? Here we go. We check this if you have problems. Congruent segments. In geometry, two objects that have the same size and shape, the size and shape are called congruent. Very important word, congruent. Congruent means equal in size and shape. Okay, for many geometric figures, we can give a more precise definition of what it means to be congruent. For example, we will define congruent segments in this section, congruent angles in next section, that's 1-4, okay, and congruent triangles in chapter 4, and congruent circles and arcs in chapter 9. All right, congruent segments are segments that have equal length. Okay, for the segments, if they are the same length, they are congruent. To indicate that DE and FG have equal length, you write DE equal FG, right? The two alphabets without any lines above it is the distance between 2 points. To indicate the segment DE and segment FG are congruent, we use this right here, this form, okay? So DE equal FG, because I told you these are numerical values, these are numbers, so you can make them equal. But you cannot do this. This is incorrect, and I will subtract points because you cannot connect them with equal because these are not numerical values. If these are geometric thing, so if you want to say these are equal, you have to tell them, you have to say these are congruent, and you have to add this, okay? So this is the size, right? Length, and that's the shape, okay? That's the shape, that's the size. Later, you're going to learn like triangle ABC is congruent to triangle DEF, for example. Okay, so that's congruent triangles, and you will learn congruent triangles in chapter 4. If you do this, so not equal, but just this squiggle, what do you think that means? This is the shape, and that's the size, right? So that means these are the same shape, but size are not necessarily equal. This is called the similarities, okay? And we do that in chapter 7? Yeah, chapter 7 or chapter 8. Anyway, it's the second half of the year, okay? So it's very important to use equal for numerical value and congruent sign for the geometric figures, okay? Read segment DE is congruent to segment FG. The definition tells us that two statements are equivalent. We will use them interchangeably. Okay. And page 6. Midpoint of a segment. The midpoint of a segment is a point that divides the segment into two congruent segments. In a diagram, AP equal PB, the distance between A and P and distance between P and B are the same because they're both 2. Then these two segments are congruent. Okay, and P is the midpoint of a segment AB. Okay, bisector of a segment. A bisector of a segment is a line, segment, ray, or plane that intersects the segment at its midpoint. Line L is a bisector of AB. And segment PQ and plane X are also bisector of segment AB. Okay, so the plane, segment, line can be all a bisector of a segment. Okay, so page 7. Okay, so I want you to do 3, 4, 5, 6, 9, and 13 right now. Okay, so stop here and then do those and then come back. And then we do the rest in the class tomorrow. And then we also do 23, 24, 25, 26 in this video. And then you are done. That's tonight's homework. Okay? All right, so come back here once you're done. Just these for now, and then we work on these after. Okay, these. All right. Okay, so number 3, is segment AB the same as segment BA? Are they? You remember it's the segment that has 2 endpoints, A and B. It's this. That's segment AB. And it doesn't matter you call it AB or BA. So this is the same. Same. Or yes. Should I say yes? Yeah, yes. Okay. Is ray AB the same as BA? So here's ray AB. And here's ray BA. So no, they are not the same. Is line AB the same as line BA? It's a line that goes through the 2 points. So it's the same line, right? It's the same segment, same line, different rays, right? So this is a yes. How about the distance between AB and distance between BA? Isn't that the same distance? Yeah, so that's a yes. Okay. Find each distance, RS and RQ and PT. Okay, so RS is 1, RQ is also 1 because it's absolute value, right? And then the PT, you can do 2 minus minus 2, which is 4, or you can do minus 2 minus 2, that's minus 4, absolute value of that is a 4, or you can count it 1, 2, 3, 4. So it's a 4, right? Number 13. What number is halfway between 1 and 2? Halfway between 1 and 2? Here's a 0, 1, and 2. So halfway between 1 and 2 should be 1.5, right? What is the coordinate of the midpoint of ST? So midpoint of ST, the coordinate should be 1.5. Okay? Right, next page. Stop here, do these, and come back, and we are done for tonight. This is kind of long video. Okay. Given numbers are the coordinates of 2 points on the number line. State the distance between the points. Okay. So let's just do, it's giving you these different signs. So it's just a practice. So you can do 6 minus minus 2 equal 8. Or you can do minus 2 minus 6 absolute value minus 8, which is 8. Either way, it's 8. Okay. Minus 2 minus 6 absolute value minus 8, which is 8. No, I'm sorry. Minus minus, it's a plus. Sorry. So that's absolute value of 4, which is 4. If we did minus 6 minus minus 2 absolute value, that's a plus 2, so that's a minus 4, then that's a 4. Okay? So that's a 8 because that's a positive 6, and that's a 4 because that's a negative 6. All right, 2 to 6. It's just the absolute value, so we don't have to think about. Oh, if you don't like absolute value, you make sure to start with larger value. So here you're starting. The minus 2 is larger than minus 6, right? So you can do 2 minus minus 6. That becomes, so that's an 8. Or if you want to do absolute value, start with minus 6 minus 2 is absolute value minus 8, which is 8. Now recall, this is from 2 to minus 6 and minus 2 to 6. It's not the same segment, but it has the same numerical value. Okay, so because the 2 is not, these endpoints are not the same, right? But the numerical value, the distance is the same. All right, 7 and 1. 7 minus minus 1 equal 8. So again, these 3 has the same numerical value, but those are different segments. Okay, done for tonight. Make sure you do the survey, okay? See you tomorrow.